All right, welcome everybody. Today we are going to talk about graphing in something called factored form. So factored form, just so you're aware, is also called intercept form. We will probably stick to calling it factored form, but you should know them by both names. So far, you have learned how to graph in vertex form and how to graph in standard form. So if you look at factored form here, it's y equals a times x minus p times x minus q. Couple things to point out here. It looks quite different than vertex form and standard form, but there is one thing that's the same. The one thing that is the same for all three of the forms is the A out front. The A out front tells you the same information for factored form that it did for both of the other forms. So let's review that. If the A is greater than 1, which of course means it's positive, it means that the graph will face up. If A is less than 1, which means it's negative, that still means that the graph will face down. If the absolute value of A is greater than 1, so something like 2, 3, 100, that means that there is going to be a vertical stretch. The way you would describe that in plain language is that the graph would be narrower than normal. If the absolute value of A is between 0 and 1, meaning it's a fraction, something like a half, a third, or a fourth, that means a vertical shrink. And again, in plain language, that means that there would be a wide graph. So again, for all the things that are changing from one form to the other, the thing that remains the same is the A value. It always tells you if the graph will face up or down, and whether or not it will be the normal width, a narrow width, or a wide width. Then take a look at the rest of the equation. So 2 parentheses, those are generally called factors, which is why this is called factored form. So it's x minus p and x minus q. Please make sure you know that these can also be additions. Whether they're minus or plus means something, which we'll get to in just a minute. So as we've seen so far, each form kind of has a set of characteristics that you're being asked to find, and you're being asked to find them in the order that makes the most sense. So because this is called factored or intercept form, the first thing that makes the most sense to find is actually the x-intercepts. So to find the x-intercepts, here's what you're going to do. You are going to set each of the factors, x minus p, x minus q, equal to 0. So x minus p equals 0, x minus q equals 0. And you should remember that you're allowed to do that because of the zero product property, which you should have reviewed during the matching introduction. If you go ahead and solve each of these equations, you're going to get x equals p, which means that one of the x-intercepts is going to be the point p comma 0, and the other x-intercept is going to be the point q comma 0. Just so you are aware, these values are always going to be the opposite of what they are in the parentheses, which means if there's subtraction in the factor, you're going to get a positive answer. If there was addition in the factor, you're going to get a negative answer. So you can set up these equations each time and solve, or if you want a shortcut, just remember that it's always the opposite, and we'll see that as we go through the examples. Once you have the x-intercept, so the axis of symmetry, remember that the axis of symmetry is the dotted line that cuts the parabola exactly in half. The way that you find the axis of symmetry is a line, x equals. You're going to take whatever the p and whatever the q from the previous step is. You're going to add them together, and then you're going to divide by 2. Before you divide by 2, be sure that you simplify whatever the numerator is first. So if it was 5 plus 8, first do 5 plus 8 and then divide by 2. So make sure you simplify the numerator first. Once you have the axis of symmetry for the vertex, whatever the x value is, x equals for the axis of symmetry, that is going to be the x coordinate of your vertex. So this is going to be the same number, p plus q over 2. Then for the y value, we call that f of p plus q over 2, which basically means that you plug whatever this is in for x, and that will give you whatever the y value is. And again, we're going to see lots of examples of these in just a minute. Then you're going to find the y-intercept and its reflection point. Hopefully you remember from your lesson in standard form that for every value to the left of the axis of symmetry, there is a mirror image on the right, and vice versa. If there's a point on the right, it's to the left. To find a y-intercept, that's the same as always. You're going to set x equal to 0, and then you're going to solve. And then to find the reflection point, you're going to use the axis of symmetry to find the corresponding point on the other side. So hopefully you've written down all these equations, and now we're going to see them in action. But again, just a quick review. This here, y equals, or remember it could be f of x equals or g of x equals. It doesn't matter what I decide to put on the left. They're all equivalent. So a times x minus p times x minus q, that a is the same a that we've seen in all the other forms, which tells you if it faces up or down and whether it will be narrow or wide. The reason why it's called factored or intercept form is because the easiest things to find are the x-intercepts. They're always the opposite of each set of parentheses, which if you can't remember that, set each parentheses equal to 0 and solve, and make sure you write those values as ordered pairs, p and q, comma 0. The axis of symmetry is always a line, x equals, and you find it by doing whatever the p is plus whatever the q is divided by 2. Make sure you simplify the numerator first. Whatever this axis of symmetry is, it's the same as the first value of your vertex. To find the corresponding y value, you take whatever this number is, plug it back into the equation, and that will give you the y value. Last but not least, to find the y-intercept, you always set the x equal to 0, solve for the y, and then use the axis of symmetry to find reflection points. So let's go ahead and take a look here at number 1. I actually drew the graph for you already, just so it's nice and neat. But of course, we need to figure out how to get there along the way. So y equals negative x plus 1 times x minus 5. And again, you know right off the bat that this is factored form because of the fact that you have these parentheses. When you see those parentheses, those are by definition factors, which means that it's factored form. You're going to go ahead and start by telling me what a is, and a is the value that's out front. So right now, all I see there is a negative. So that means that a is equal to negative 1. The fact that a is equal to negative 1 actually tells us two things. It tells us that the graph is going to face down because it's a negative, and it tells us that the width is actually going to be what I call normal. Whatever the width of this parabola is will be equivalent to the normal width of the parabola. So you don't have to say that it's normal, but I like to. Again, as opposed to being normal, it could be narrow or wide. So by being normal means it should be just normal width, but the negative means it is going to face down. To find the x-intercepts, you're going to look at each of the factors. X plus 1 equals 0, and x minus 5 equals 0. If you were to solve each of those, you would wind up getting negative 1 for the first one, which is negative 1 comma 0. 5 for the second one, which would be positive 5 comma 0. And again, if you're looking for a shortcut, if you don't want to set up these equations, you just do the opposite and the opposite. It is always the opposite. Disregard the a on the outside. The a already did its job. It told us whether we were facing up or down and whether we were narrow or wide. It does not have an effect on the x-intercept. So those are always the opposite. To find the axis of symmetry, if you take a look at the left, we have to do x equals p plus q over 2. So negative 1 plus 5 over 2. Do the numerator first. So negative 1 plus 5 is 4. Divided by 2 is 2. It doesn't always simplify to be an integer, but it's nice when it does. Then the vertex is an ordered pair. The first value of the vertex is the same as whatever the axis of symmetry is. So I know that it has to be 2. To find the y value of the vertex, I have to go back to my equation. Everywhere there is an x, I'm going to plug in a 2, and that's going to give me the corresponding y value. So that's going to be y equals negative, don't forget the negative, 2 plus 1 times 2 minus 5. You can either plug that into your calculator exactly as it appears, or you can go ahead and do it step by step. It really doesn't matter. So if you go ahead and do those calculations, you're going to get negative 2 plus 1 is 3. 2 minus 5 is negative 3. And if you multiply negative times 3, you get negative 3. Negative 3 times negative 3 is positive 9, which means that the vertex is the point 2, comma 9. We're going to go ahead and take everything we found so far and we're going to graph it. And again, I already have the graph for you just so it's nice and neat, but then all the other ones we'll go ahead and do step by step. So starting with the x-intercepts, negative 1, comma 0 and 5, comma 0. Negative 1, comma 0 is this point right here. And positive 5, comma 0 is this point right here. Remember that the axis of symmetry is always a dotted line that goes halfway through your parabola. So that dotted line right there, that is the axis of symmetry, x equals 2. Remember, it's always a vertical line, and we typically draw it as a dash line so that we know that it's not really there, but it helps us to kind of guide the graph. And then, of course, the vertex is the point right here, which is the point 2, comma 9. So as you find each of these values, they should, of course, be corresponding points on the graph. And then the last thing we're being asked to find is the y-intercept and its reflection point. So remember that for the y-intercept, you're always going to set the x equal to 0, and then you're going to solve. So again, if you go back to the equation, everywhere there's an x, you're going to put a 0. So here's a copy of the equation here. So I'm going to keep the negative on the outside. 0 plus 1 gives me 1. 0 minus 5 gives me negative 5. Negative times 1 times negative 5 gives me a positive 5, which means that the y-intercept is the point 0, comma 5, which if you look closely at your graph is located right here. Then last but not least, the reflection point means there should be a corresponding mirror image on the other side of the axis of symmetry. So if you look at how I got to that point, you're basically looking what is the distance from the axis of symmetry to that value on the left. You're now going to go the same distance from the axis of symmetry to the right. So that 0.05 is 2 units to the left of the axis of symmetry, which means if I go 2 units to the right of the axis of symmetry, I should get the corresponding mirror image point, which is going to be the point 4, comma 5. So this is what is considered to be a high quality graph. It has the vertex, it has the x-intercept, it has the y-intercept, and then it has a reflection point on the other side. Your graph only gets better the more points you choose, but generally speaking, these 5 are usually enough, although in the upcoming examples, we'll find a few extras just to be sure. Let's go ahead and try a few additional examples, starting here with number 2. So g of x equals 2 times x plus 3 times x plus 1. And again, remember, y equals, f of x equals, g of x equals. They're all equivalent, so please be open to seeing any of those forms. The first thing that you're going to do is you're going to identify the a, and we can actually talk about the a for each of these at the same time. Remember that the a is always the value out front, and if there's nothing there, that means that a is positive 1. So a has to be something, but if it's not there, it's implied to be a positive 1. So in this case, a is 2. What that means is that the graph is going to face up, and it's going to be narrow. The fact that it's positive means up. The fact that it's 2 means narrow. Compared to number 3, negative 1/2. Oops. So negative 1/2. That means that the graph is going to face down because it's negative, and the fact that it's a half means it's going to be wide. So by describing the width as normal, narrow, or wide, it just kind of helps you to have a visual of what it is that's supposed to happen as you go through these problems and what your graph is supposed to look like. If you say that the graph is supposed to be wide and it isn't, that's a problem. If you say the graph is supposed to be narrow and it isn't, that's a problem. So now for the x-intercepts. To find the x-intercepts, you're going to look, at each of the parentheses. And again, by definition, it's always going to be the opposite. So if you have x plus 3, that means that your first x-intercept is going to be negative 3, always comma 0. Then if you look at x plus 1, your x-intercept is always going to be the opposite, which will be negative 1, comma 0. Again, if you are not able to just always remember that it's the opposite, you would set each parentheses equal to 0 and then solve. When we say P and Q, it actually doesn't matter who's P and who's Q. We typically just go who's ever first is P, who's ever second is Q, but it doesn't matter if you decide to swap them. And I think it actually might be helpful to kind of look at these two together step by step. So if you take a look at number 3, you'll see that this is actually a little interesting because there's only one obvious factor, which is x plus 8. And then you kind of have this hidden little x here. So that x by itself, that is still considered to be a factor. Whenever you see an x by itself with no plus or minus, that automatically means that the answer is 0. And then x plus 8 is going to be that the answer is negative 8. Again, if you're not clear why that is, remember that your option is always to take each parentheses and set it equal to 0. And if you set x equal to 0, there's no work to do, and you just wind up getting 0. So that's kind of a little bit of a special case of factor form when you just have that lonely little x there, but please make sure you don't disregard it. That x is really the same as x plus 0. And if it would help you to write it as such, then you should do so. Otherwise, just make sure that you remember that when you see that lonely little x, it automatically means 0. To find your axis of symmetry, remember that you're going to do P plus Q divided by 2. So negative 3 plus negative 1 divided by 2. Do the numerator first. That's going to be negative 4 divided by 2, which is, of course, negative 2. When I go to do my axis of symmetry on the right, 0 plus negative 8, negative 8 divided by 2. That's going to be negative 8 divided by 2, which is going to be negative 4. Remember, it's nice when all the values turn out to be integers, but they don't have to. I only had 3 examples that I chose, so I can't show you one of every single kind, but just make sure you know that they don't have to be integers. So now for the vertex, to find the vertex, you are going to take whatever the axis of symmetry is, you're going to plug it into the equation, and that is going to give you the corresponding y value. So to find the vertex, you're going to do y equals, leave the 2 from the front, plug a negative 2 in for the first x, plug a negative 2 in for the second x, and then go ahead and perform that calculation. So again, you can plug that all into your calculator exactly as it appears, or you can go ahead and do it one step at a time. So that's going to give you 2 times 1 times negative 1. 2 times 1 is 2, times negative 1 is negative 2, which means that your vertex is going to be the point negative 2, negative 2. Just a coincidence that they both wound up being the same value. Perfectly fine if it happens, perfectly fine if it doesn't. Let's go ahead and finish number 2 all the way through, and then we'll go back and finish number 3. So I have the vertex 2, negative 2, negative 2. And in fact, if I wanted to, I can start by going ahead and graphing those values. So if I bring up my graph here, I'm going to go ahead and start with the x-intercepts. So the x-intercepts are the point negative 3, comma 0, and negative 1, comma 0. And then the point negative 2, negative 2. Remember that the axis of symmetry is a dotted line through the vertex. So there's my axis of symmetry, which is x equals negative 2. That is what is supposed to split the graph exactly in half. To find the y-intercept, remember, you're going to plug a 0 in for all of the x's. So that is going to be y equals, don't forget the 2, 0 plus 3, 0 plus 1. That's going to give me 2 times 3 times 1. That's going to be the point 0, comma 6. So bringing up my graph here, the point 0, comma 6 is going to be a point on the graph. Then remember, for every point that you find to the right of the axis of symmetry, there has to be a mirror image point on the other side of the axis of symmetry. So because that value is exactly 2 units to the right of the axis of symmetry, that means if I go 2 units to the left, I should have another point. I can see my graph kind of starting to take shape there. So again, 0, 6, and then the mirror image would be the point -4, 6. Truth is that most of the time that is enough points on the graph, but you can always find more. If you ever want to find more, you just pick any x you haven't already chosen. So let's say that I wanted to find one additional point, and let's say that I wanted to choose x equals 1. If I wanted to choose x equals 1, I would go back to my equation. Everywhere there's an x, I would plug in a 1, and it turns out that I would actually get the point 1, 16. Notice that in this case, it would be slightly off the graph, which would be fine. Because the point 1, 16 would be exactly 3 units to the right of the axis of symmetry, that means if I go 3 units to the left of the axis of symmetry, there should be its reflection point, which would be -5, 16. And again, those are slightly off the graph, so it's fine if I don't graph them. I'm going to go ahead and connect the points that I do have. And again, my graph is not perfect here because of my stylus, but it looks pretty good. So again, you have the vertex at the bottom, the 2 x-intercepts, which are mirror images next, and then last but not least, the y-intercept and its corresponding point on the other side. So again, that is considered to be a high quality graph because it has at least 5 points. And go back to the beginning, you told me that this graph should face up and be slightly narrow, and I think that is a pretty accurate description of what is taking place here. Finally, let's go ahead and finish up number 3. So just to reiterate, -1/2 means it's going to be wide and face down. The x-intercepts are 0 and -8. And remember that 0 comes from that lonely little x. P plus Q over 2 gives me -4. To find the second half of the vertex, I'm going to go back to my equation. Everywhere there's an x, I'm going to plug in a -4. So that's going to be -1/2 times -4 for the lonely x, -4 plus 8 for the second parentheses. Again, feel free to calculate that step by step, or you can just go ahead and plug it into your calculator. That's going to wind up being, so -1/2 times -4, that's +2. -4 plus 8 is 4. 2 times 4 is 8, which means that the equation of my vertex is going to be the point -4, 8. If I want to graph what I've got so far, let's take a look here. So starting with the x-intercepts, so 0, 0 is the origin, -8, 0 is here. Then the vertex is in the middle. That is the point -4, -8. Sorry, -4, +8. Then the axis of symmetry is, of course, always the dotted line that goes through. So that's the point x equals -4. That's what's going to split our graph exactly in half. And again, make my vertex a little bit bigger here. Go ahead and talk about the y-intercept, which means put a 0 in for all of the x's. So y equals -1/2 times 0 times 0 plus 8. And here's the thing, because I have this 0 here, that means that as I multiply, I am going to get a 0 no matter what, which means that the y-intercept is the point 0, 0. And here's where it gets a little bit interesting. So you'll notice that 0, 0 is already on my graph. It's not only the x-intercept, but in this case, it's also the y-intercept, which means the mirror image to 0, 0 is over here at -8, 0, which means these are points that I've already found. So this is a case where some of the values are not the answer to just one question, but the answer to 2. So the point 0, 0 and -8, 0, those are both the x-intercepts and the y-intercept and its reflection point. So that's why it might be a good idea in this case to choose additional points. Right now, I only have 3 values. Again, that's not awful, but it would be nice if I had additional points. So again, to do that, you literally pick any x that's not already included and then plug it in and find the corresponding y value. I happen to like choosing 1. In this case, if you choose a 1, you actually get a decimal, which is negative 4.5, which I actually think is good to see a decimal since we haven't really seen too many. So the point 1, negative 4.5 would be right here. And then, of course, there is a corresponding mirror image point on the other side. So the point 1, negative 4.5, that is exactly 5 units to the right of the vertex, which means I have to go exactly 5 units to the left of the vertex to find the corresponding other point, which would be the point negative 9, negative 4.5. And you don't have to choose these specific values. Remember, they could be anything as long as it's not a value you've already chosen. So go ahead and connect the dots. And again, your graph should be even better than mine since my stylus is not the best here. But your graph should, of course, be symmetrical, which I think it is. And then last but not least, go back to the top. You told me that the graph should face down and be wide. And if you look at that graph, I think it's a pretty accurate description. So these are just 3 of the possible graphs in factored form that you're going to be asked to do. You're now going to be asked to do 3 more for homework. So thanks very much for tuning in, guys. Feel free to watch this video as many times as you might need, and we will catch you next time.